In example 2, we're going to be looking at an application problem involving mixtures. Here's an example. It says a nurse mixes 60 cc's of a 50% saline solution with a 10% saline solution to produce or she wants that to equal, a 25% saline solution. How much of the 10% solution should he use? On these types of problems, I like to go ahead and say that we're going to let X be equal to the cc's of the 10% solution. That's what the unknown will be. Now, notice that we're mixing two quantities together. I like to draw a graphic organizer that shows we're going to be mixing two quantities together. We're going to be taking that chunk plus that chunk to result in, well, what we want that to result in. Mixing things together, adding those things together. Now, to label this, I like to put percents on the outside, kind of like you would label the percentages of the saline solution on the outside of the bottle, and put amounts on the inside. The nurse starts with a 50% saline solution. So in decimal form, again, we're going to be taking these percentages and turning those into their decimal equivalents, 0.5, okay? So there's 50% saline solution, saline, okay? And we have the amount is 60 cc's. The nurse is going to add to that a 10% saline solution, 0.1 saline, and we don't know how much amount that is. That is what we let X be up here. So we're going to put that amount inside. Now, the nurse wants that to be a 25, to that mixture to result to a 25% saline solution. They want to get 0.25, 25% saline solution. And the question here is how much is going to result when we add 60 cc's to X cc's. That is going to result in 60 plus X cc's. Okay? Now, once you have all the percentages like we have labeled up here as well on the outside, and then all of the amounts on the inside, to set up your mathematical model you'll use to solve this mixture problem, it's a matter of just taking percent times amount. So 0.5 times 60 is the amount of saline we will have in the 60 cc's. Okay? The next, we take the percent, 0.1 times the amount, X. We have 0.1 X equals, over here, percent times amount. Now, for this, since you have two terms, the amount you're going to need to write as a quantity. So we take the percent, 25% or 0.25, times the quantity, 60 plus X, and that will be the amount of saline we want in our resulting mixture. Now you see we have an equation set up that has one unknown. We can solve this. Okay? 0.5 times 60 is 30 plus, bring down the 0.1x, equals 0.25 times 60 is 15 plus 0.25x. Once we distribute the 0.25 through to each of those terms. Now it's a matter of getting constants on one side, variables on the other, and to keep from having to deal with negatives, if I subtract 15 from both sides, move my constants to the left-hand side, and subtract 0.1x from both sides, There's the same thing as 0.1x. That'll keep me from having to deal with negative amounts in my problem. 30 minus 15 is 15. Let me change back to black here. 30 minus 15 is 15 on the left-hand side. On the right-hand side, 0.25x minus 0.1x is 0.15x. Now we're going to divide both sides by 0.15 to solve for x. So, 15 divided by 0.15 is 1,000. Let me crunch that on my calculator real quick, actually. 15 divided by 0.15 is 100. Sorry. I knew that wasn't looking right. Okay, 15 divided by 0.15 is 100. That is equal to x on the right-hand side. So remember what x was. Go back and refer to your sentence. X is the number of cc's of the 10% solution. So if we add 100 cc's of the 10% solution to that 60 cc's of a 50% solution, that will be the correct proportions to add together to give us the 25% solution that we need. And we will actually end up with 160 cc's of that 25% solution. But 100 cc's of the 10% solution is our answer. That's what the problem asked us to find.